Hello and welcome to the June 2022 AstroQuest. My name's Kevin Kupczynski. I do astronomy and other types of STEM education here at the museum. I am joined by Rich Sanderson, the president of the Springfield Stars Club, and Caitlin Goulet, a member of the Springfield Stars Club. And we're going to join up to bring you a program tonight. We'll be thinking a little bit about the solstice, and then we'll be looking at what's going on with the planets in the morning. We have a hopefully big morning coming up on Friday, and other mornings coming up before Friday and just after really are pretty cool too. And we'll have a little bit of a look at the night sky and everything. And thank you in the chat. Marguerite. Oh yeah, the Arecibo. Yeah, we had a nice presentation, and you can still see that online at the museum site. You can get a link to some of the past of Stars Over Springfields when we were doing those virtually, and the past AstroQuest as well. So let's go ahead and get started. Rich, so Rich Sanderson, as I mentioned, president of the Springfield Stars Club. Rich, so maybe you'd like to say a little bit about the club for a moment, and then we'll get your pictures up.
Oh, sure. Thank you, Kevin, and welcome everybody. Yes, I'm the president of the Springfield Stars Club, which is a amateur astronomy club that's been active in this area since 1934, and it now meets at the Springfield Science Museum as it's done for the past 50 years or so. And the meetings are held from September through May. So there's no meetings during the summertime, but they resume again in September on the fourth Tuesday of every month at 7 o'clock. So fourth Tuesday at 7 o'clock. Anybody that's interested or wants to join or just check it out, you're welcome to just show up at one of our meetings in September or October, any month on the fourth Tuesday. And, you don't have to join right away. You can make sure it's something you want to do, but it's a bunch of people that have a common interest and passion for the night sky and astronomy and telescopes and everything associated with those topics, but nothing highly technical. It's popular astronomy, so it's a good time. A lot of people, different ages, different levels of expertise. So it's a fun club. So that'll start up again in September. And during the summer, members will be going to conventions such as Stellafane up in Springfield, Vermont, which is one of the biggest and most famous astronomy conventions in the country that happens on the last weekend of July. It's actually a telescope making convention, but it's basically all areas of amateur astronomy. If anyone's interested in that, their website is Stellafane, STELLAFANE.com. And you can get registration information or see pictures or what have you if you want to look into that. I want to say what a pleasure it's been to do these programs since we started the AstroQuest, and Kevin, of course, has been running these shows, and Caitlin has been participating, and it's really been a fun time sharing our love of the night sky and local astronomy with folks, just so that everybody knows that there's a lot going on in STEM and science and astronomy in Western Massachusetts. And one of the people that's really done so much for local astronomy and local STEM education is the leader of this program, Kevin Kupczynski, who I had the pleasure of working with for a couple of decades. And Kevin is an outstanding scientist, an outstanding STEM expert, a wonderful planetarium presenter and programmer and show creator. And, he's taught so many people and inspired so many children about science and astronomy. And that's something that's sorely needed nowadays, is to promote science, especially among kids. And I wasn't sure if Kevin was going to mention it or not, but he's a little too humble to mention that he just got a major promotion at the Science Museum, which I just found out about a few minutes ago. And Kevin has been promoted to STEM curator. It couldn't be more well-deserved, Kevin, for all that you've done for the museum, for the planetarium. I couldn't have done my job as whatever accomplishments I had when I was at the museum wouldn't have been as good if it wasn't for working with Kevin as a partner in the planetarium and in the observatory and with all the astronomy programming. And it's just makes me so pleased and so happy to see you promoted to STEM curator, Kevin. It's a very prestigious position at a museum to be a curator. And Kevin, you surely deserve that. And congratulations.
Thank you so much, Rich. Thanks so much. I really appreciate the comments. Yeah, it's exciting, and we have a lot of exciting things that are going to be coming down with our observatory and our planetarium in the next year or so. So this is exciting, and should also add, I did introduce Rich as the president of the Stars Club, but as he mentioned, he used to be a curator here himself, and recently we've kind of readopted him on as a curator emeritus. So there's you can't, we don't want to lose good people, so glad that you're still around and helping out, Rich.
Well, part of the reason I'm still around is because of folks like you and the new director, Jenny Powers, who I know is watching right now. And between Jenny and Kevin, people in Western Mass are really going to flourish and benefit in the field of science, thanks to these two individuals who are going to be it's going to be a focal point of STEM and science education and inspiration to the next generation of scientists and astronauts right here in Western Mass. So that being said, let's look at a couple of my pictures that I have here. I like to share pictures that I've taken from my backyard or from the local area. And usually I just use a iPhone. Let's see, that's a rainbow that I saw recently here in Agawam, and you can see there's a secondary rainbow. It's actually a double picture, but I guess it's too big for the
Yeah,
screen.
I see that too, Rich, and I'm not sure why it's not all showing
Yeah.
up at once.
But yeah, that's probably a better one. That was from the local school playground. It's tough to find a nice low horizon without telephone pole wires and different houses and buildings interfering. But the school playground is a good place. And what's interesting is a lot of times rainbows appear against a gray, gloomy, dark gray background of clouds because you have to have rain droplets to form a rainbow. But this double rainbow appeared in a sky that has blue patches. So there's obviously clouds of water droplets being blown opposite the sun. So the sun was setting in the west. So this is looking due east because the rainbow circles the shadow of your head. So it's in the opposite direction. At sunset, the rainbow would be in the east, and at sunrise, it would be in the west. And the rainbow, as the sun goes down, the rainbow rises up 42 degrees. So it circles the shadow of your head. So the lower the sun is, the higher and bigger the rainbow is. And this picture was taken about 5 or 10 minutes before sunset. So it's almost the maximum semicircle rainbow. There you go.
Okay, yep.
And it's just such a beautiful example of nature's geometry. And what's happening is raindrops, as raindrops are falling through the sky or being blown through the sky, they're not droplet shaped, like a teardrop, but they're actually spheres, or sometimes kind of oval shaped spheres floating in the air. And as the sunlight hits the raindrops, it refracts into these little tiny droplets and bounces off of them and refracts back out. They're like little tiny glass prisms. And if you remember, in school, we always used to have prisms, and you'd hold it up to the sunlight and it would make a spectrum. It breaks the light up into the colors of the spectrum as they pass through the glass. Well, the same thing happens with a raindrop. It breaks the sun light up into the colors of the spectrum and reflects it back to the observer. So So that's why the rainbow is in the opposite direction of the sun. So the primary bow is the bright one, and the secondary bow is the outer rainbow that you can see here, the faint one. In the bright rainbow, the sunlight is bouncing off of the inside of the raindrop once and then coming back out. And in the secondary bow, it bounces off the back of each droplet twice. So it's at a slightly different angle. So it appears outside, they're concentric circles. And it also appears dimmer because of that second bounce, it loses light. And so the secondary one is dimmer. There's actually a third order and a fourth order rainbows, which are extremely rare. And those appear near the sun in the sky, not opposite the sun, but near the sun. And the geometry is kind of complicated, but they're so rare that it's only been fairly recently that anybody's ever succeeded at getting a picture of a third and fourth order rainbow. With digital photography and enhancement and all that, they've managed to do that. But fortunately, the ones that we see here are fairly common. The next picture just shows a close-up of one side of it. And one thing to see as the outer bow, as I said, it makes an extra reflection. And what that does is it flips the colors around. So on the inner bow, the red's on the outside. And if you can just barely see the outer bow, the red would be on the inside. So the colors are opposite. And oftentimes the area inside the bow is brighter than the outside, but you don't really see that too well in this one because the sky was bright. But this is something to keep an eye on during the summertime. If there's a storm and the sun is low in the sky and peeks through a hole in the clouds, when it's low in the sky, go outside and don't look toward the sun, look toward the shadow of your head. And that's where you might see a rainbow. And the last picture is just a picture of the full moon that I took on June 13th. It's amazing what you can do with iPhones today. And this was actually, the moon was through a thin cloud and it came out as a fuzzy, almost featureless disk in the picture. But just by tweaking it using the tools on my iPad, enhancing the contrast and playing with some of the brightness and other tools on there, I was able to bring out the features on the full moon and kind of erase the clouds, which is just remarkable what you can do nowadays with digital photography. And it's just holding an iPhone to the eyepiece of my telescope. This is what I got. And you can see Tycho at the bottom. Looks like a belly button there with rays coming from it in all directions. And the lava plains, which are the grayish features, and the highlands are the bright features in the lower right area. The beautiful, beautiful full moon. But no werewolves that night, just a full moon.
Okay. Thanks, Rich.
You're welcome.
Yeah, the moon is the moon is always just great to look at, I think, and sometimes we, especially in astronomy, we end up kind of the moon is like the bad guy because it keeps us from seeing other stuff. But well, you might as well look at that then. It's really interesting to learn about some of the geology that's on there that you can start to see through a backyard telescope. Okay, so before we continue, I also do want to point out a couple of things. One, please feel free to post questions or comments in the chat. You could also use the question and answer feature, although sometimes that's harder for me to find. So I usually can keep the chat up where I can see it. So please feel free to do that. We more than welcome any questions that you might have during the program. So now I'd like to introduce Caitlin Goulet. Caitlin is a member of the Springfield Stars Club. Caitlin has been observing the sky and using telescopes since she was a little kid. And now she's writing a newsletter. Newsletter has now been in publication for over 2 years. And so we really enjoy the opportunity that we can let her share some of her enthusiasm of the night sky with you all. So, Caitlin, go ahead and take it away. And what do you got for us this week?
Thank you for that introduction. Hi, my name is Caitlin Gillette, and tonight I'm going to give you guys the Observer's Scoop. So as Kevin mentioned, I do write a monthly space and astronomy newsletter called the STARRY Scoop. It has been in publication for over 2 years now. I've had such a blast writing it. If you guys would like to receive a copy, I have a Facebook page, and you can also reach me at my email, which is starryscoop@gmail.com. So before I get into my presentation, let me explain a little bit about constellations. There are 88 official constellations in the sky, and I always explain them as puzzle pieces. They each take up their specific region in the sky, and they fit together perfectly to create the entire celestial sphere. Now, astronomers and stargazers recognize these constellations with their bright stars creating star patterns or asterisms. Tonight, we will be exploring the constellation Ophiuchus. And I have a star map on the right-hand side, and here's the star map. The lighter area is the official constellation, so that's its quote-unquote puzzle piece in the sky. And then we have its bright stars connected with lines. And in this picture in the middle, you can see its bright stars really standing out and against the black background. And this is what the constellation would look like under dark skies. Now, Ophiuchus is also known as the serpent bearer or the medicine man. We can even recognize him in modern days with the modern day medical profession symbol being a staff, a winged staff with a serpent wrapped around it. So I thought that was pretty cool. So let's get into some of its stars. We have Razelhagu, the brightest star in Ophiuchus, shining at 2.1 magnitude. It's right here. We also have Barnard's star, which is found right here with the arrow. Barnard's star is a red dwarf star, and it is the second closest star to Earth at 6 light years away. And it's only beat by the Alpha Centauri system. And something cool about this is it's actually moving super fast in space. And eventually it will surpass the closeness of the Alpha Centauri system and be the closest star to us. Another thing worth mentioning is Kepler's supernova. This used to be a star, but it reached the end of its lifespan, and it imploded and then it exploded, and it became a supernova remnant. It went supernova. So in 1604, astronomers saw it, and it shined brighter than any other star in the nighttime sky, and it even appeared in the daytime sky for about 3 weeks. Nowadays, it is dimmed by a lot. You need a telescope to see it, and it's found right here where this arrow is pointing. And I also have a picture right here. This is by NASA. It's enhanced, so this is not what you would see in a telescope. On my star map to the right, you may notice some circles I have around a few stars. That marks the double stars for a telescope. Now, double stars are some of my favorite objects to observe. To the unaided eye, they appear as a single point of light. But if you enhance your view with a simple pair of binoculars or a telescope, 2 or more stars can be revealed. They're just a nice, fun challenge. And sometimes the color contrast between those stars is just wonderful. You have reds with whites, oranges with blues. They're just wonderful. It's like seeing a waterfall or a rainbow. Ophiuchus is home to many globular clusters. There is no other constellation that has as many globular clusters as Ophiuchus. Now, globular clusters are clusters of old stars bound together by gravity. Now, the cool thing about globular clusters is that they orbit in the halo of our galaxy. An example of this, if you look at this photo right here, here is an edge-on view of a galaxy. And this is where the globular clusters orbit, kind of near the center. Now, in Ophiuchus, right around here is where the center of the galaxy is. So when we look towards Ophiuchus, we're looking at the downtown part of where the majority of the globular clusters are located. So if you take a simple pair of binoculars or a small telescope and just scan this region, you'll find dozens upon dozens of globular clusters, which is just amazing. I like to think of them as just balls of glitter in the sky. We have a photo right here in the center from NASA, and this is kind of what they look like. Over on the left here, we have a list of some of the brighter globular clusters located in Ophiuchus. We have M9, M10, M12, M14, M19, M62, M107, and NGC 6304. And back on this map, they're all located here. We have M12, M10, M107. All the little yellow dots are the brighter globular clusters. There are many more, just the map only shows the brightest. We also have a few binocular objects. We start with NGC 6633, which is an open cluster. It's located around right here. This is a large and bright open cluster located about 1,000 light years away. Now, open clusters are star clusters with younger stars, and these stars are all siblings. They're all born from the same gas cloud, but their stellar winds are kind of pushing them apart, and they're moving apart over time. And eventually, they'll just become farther and farther away. A great example of this is the Big Dipper asterism. Most of the stars that make up the Big Dipper asterism used to be part of the same open cluster. Just over time, they moved farther and farther apart, and they're no longer a cluster. We also have IC 4665, another open cluster. It's found right here. This is very bright, but very sparse. So it's loosely held together, very loosely held together. And it's about 1,400 light years away. These photos here are just some examples of the different open clusters you could see. Now, we also have some deep sky objects. These are fainter, so they require some higher power, some larger telescopes. We'll begin with NGC 6572, a planetary nebula. It's located right around here. This is about 2,600 light years away and is a great telescope object because of its abnormal brightness. We also have the Twin Jet Nebula. This is personally my favorite one that I'm talking about tonight. This is what you call a bipolar planetary nebula. So its central object is not a singular star. It's actually two stars that are part of a binary star system. Here's a photo of it NASA has. And then here it is located in the star map. Now, my final object I have here is the Little Ghost Nebula, or NGC 6369. This is a planetary nebula, and it's a bit fainter, so you will need some higher power to view it. Here's a photo of it. And again, these photos are enhanced, so this isn't what you would see in a telescope. And here it is on the map. I would like to thank you all for watching. Clear skies, and remember to keep looking up.
Thanks so much, Caitlin. Before we move on with the program, I do want to mention that this will be our last AstroQuest until September. We will be taking July and August off, sort of, but we're not really taking off in July. In July, as you may know, the first science images will be coming down from the Webb telescope. We covered the launch of that last December. It successfully got out to its place of operation about 1 million miles away, and it's been calibrated, tested, and so on. Everything seems to be working well, and they are planning to send down the first image in July. Okay, it'll be Tuesday, July 12th. And check the Science Museum's webpage for information on a program. So we will be doing a program. It will be at the museum. And also, we think we're going to do it virtually as well. Check the website of the museum starting in early July, and you'll be able to see information about that event, and we'll hope to see you there, and be very interesting to see what they're bringing down. So AstroQuest will return in September as a virtual event. Stars over Springfield will return on the first Friday of the month, and that will be an in-person event at the museum. So we're looking forward to resuming that. One thing about live astronomy in the summer, it's kind of tough because you have to wait a long time for it to get dark. Okay, and that is because, well, that's where we've got the summer solstice right about now. wanted to just very quickly go mention that, and then we'll take a look at some things in the night sky. And especially, we're going to look at the planet, excuse me, the planet conjunction. I've got a view looking, this is today's date, and you can see the sun noted there in the sort of middle of the picture. Let's see if we can get that. Okay, so, and also you see the moon as well, but we're going to be really interested in the sun. And this is, I think, just set for some time in the morning. And as I said, it is set for today. So the idea of the solstice is that as if you watch the motion of the sun in the sky from day to day, as ancient people did, you would notice something. And what I'm going to do is I'm going to just run. I'm running time backwards actually. And now we're sometime. You might have noticed that that sun dipped down. It went down a little bit. So we're back into April, and what people noticed is, and we're keeping the time of day the same. I believe it's something like around, it's around the middle of the morning sometimes. So we're looking out to the east. And what people noticed was that from day to day, the sun would appear to be a little bit higher in the sky as we move from April towards June, really from moving from December towards June. The sun appears to be higher and higher in the sky. And maybe you can see that moving. I should also mention that it's a good idea to have lights, turn off the lights in your room so you can see the screen a little bit better. And we can see the sun moving, getting higher and higher. But then as we get into late May and into June, it's harder to notice that it's moving. I'm still advancing each day at about the same rate. And now it seems to have slowed down. It's still going a little bit, but on the 21st, on the summer solstice, that is the day when that upward motion appears to stop, or that upward apparent motion stops, and then it will start back on its way down, but it slows down, stops, and then starts on its way down. So solstice is the sun still day. And so and at that time of year, of course, we have long days and short nights. And it's you got to wait a long time for it to get dark enough to see things at night. But there are really some things that are worth looking at. So let's go ahead and look into the night sky. I like to actually show you that I'm moving the time because you know why you're seeing things change and what's happening. So we'll move it. So boy, look at this, 21:04, 9:04 in the evening. And it's still, we've got a lot of sun glow out in the sky. And it really needs to get down. We're about 9:30. And really about 9:30 is when you can maybe just start to see some stuff. So we'll get that down a little bit after 9:30 and look. And in the northern sky, or actually northwestern sky, we can see the Big Dipper. I'm going to zoom in a little bit here. That thing's a little bit bigger. We can see the Big Dipper kind of coming down bowl first. During the spring, it was high in the sky, and now as we move to summer, it's toward the western edge of the northern sky, or northwest, and it's kind of coming bowl first. And day by day, if you'd be able to mark its height against some landmark around you, you would notice that getting lower and lower, or start as the months go on. And then in our southern sky, we're picking up, there is the Scorpion, okay, Scorpius. And that's sort of the start of our sort of traditional, maybe summer constellations. I mean, we still have some other other things out there. There's the Big Dipper. You curve around. We've got the star Arcturus and the constellation Bootes, and the star Spica, part of the constellation Virgo. So those are still out there. And Leo is getting lower in the western sky, but you can still you can still see that as well. There's, I think, parts of Leo right there. And we still got some sky glow here, so it's hard to see the front end of the lion there. So those are sort of the spring constellations disappearing. And then we have the summer constellations coming in. There is the Scorpion. Behind that will be Sagittarius. You might have noticed that along with the Scorpion in Caitlin's star maps. And then the serpent bearer Ophiuchus is up in this area, up above and to the left of Scorpius. Over toward the east, we're going to have this summer triangle. We've got the bright star Deneb in the tail of Cygnus the Swan, the wings of Cygnus the Swan, and then moving forward, the swans have a long neck. Moving forward, a dimmer star there, which marks the beak of Cygnus the Swan. The star is called Albireo, and Caitlin mentioned double stars. This one is very distinctive yellow and blue. I'm not sure if you can if you'll see them as separate stars in binoculars, but certainly with a low to moderately powered telescope, you can do that, and the colors will really stand out. Up above the bright star Vega, part of Lyra the Harp, and down below Altair, part of Aquila the Eagle. And you see how these three stars make up this triangle, and it's called the summer triangle. Notice that here it is, it's summer. We're looking to the east. This is starting to come into our evening sky. Hence the name, the summer triangle. You're really going to be able to see the summer triangle all through the summer, all through the fall, and even a bit into the early winter. So wanted to come back a little bit to Ophiuchus. As Caitlin mentioned, it is Ophiuchus represents the Ophiuchus just means serpent bearer. That's not a person's name. The person's name is Asclepius. And he was the Greek founder of medicine. Asclepius learned medicine from a centaur, actually, and became a great healer. In the star pictures often show a figure here with one foot kind of stomping down on the scorpion. Perhaps signifying that he is able to cure the sting of a scorpion as a doctor. And he's holding in the sky. This is an interesting setup here because you have Ophiuchus, and on either side of Ophiuchus, you have a snake constellation. The head of the snake over on one side, the tail of the snake behind, and in the pictures, Ophiuchus is shown holding the snake. And so he's got this snake. Snakes in many traditional cultures, I think maybe cultures close to nature, they had a very different view of snakes than maybe a lot of Western cultures do. They notice the snakes shed their skin, and if you've ever seen a snake after it's shed, it looks shiny, it looks brand new, and people notice that. And whether they thought this literally or not, they certainly thought this idea that this snake renewed itself and that it must have some secret powers of renewal. Ophiuchus is, or Asclepius, I should say, is holding that snake, maybe as a symbol that he's mastered those powers. And then the symbol of medicine is now the snake wrapped around the staff, and that is supposed to be the staff of Asclepius. And it should be a single snake wrapped around a staff. Unfortunately, there are some organizations who have screwed up, and they, instead of that combination of the staff and the snake, that's called the caduceus. Some organizations have screwed up and instead used the symbol, the caduceus of Mercury or Hermes, which is two snakes wrapped around a staff. But it really should be just the one. So there that is. Now, the other interesting thing about Ophiuchus is that it is actually a 13th zodiac constellation. And in order to do that, we'll put up a line here called the ecliptic. Okay, the ecliptic is the path that the sun appears to take through the stars. Now, I showed you before, day by day, the sun was moving, right? And if I had shown you that with the stars turned off, I'm sorry, not the stars, the atmosphere turned off, and you could see it against the background of stars, the sun is moving or appearing to move against the background of the stars. And again, I'm careful to say appearing because it's really us who are moving. And, you know, Rich mentioned, working with kids, for most of that 20 years that I've known Rich, I was taking the portable planetarium out to schools. And what I like to, one way I like to think about it is, you know, we've all had this experience of sitting in a vehicle. And as we're moving, as we're traveling in our vehicle, we kind of feel like we're just sitting there, and we look out and the scenery is going by. And the further away the scenery is, the slower it goes by. Well, that's pretty much what's happening here. We're on Spaceship Earth. Spaceship Earth is traveling around the sun, and every night when it's clear, we get to look out the window and see the stars. Now, we can't see the sun, of course, at nighttime, but the stars are so far away that they just don't appear. They don't appear to move as we sit there or stand there and watch the sky, but slowly but surely they do. And this is why we have different stars at different seasons. The sun appears against this background of the stars, and so it appears against different stars as the weeks and months go by. And you can plot that position of the sun against the stars. You would get this line called the ecliptic. And we see the ecliptic. There's the scorpion right there. There's the serpent bearer. One of his legs sticks down, and actually the sun is going through the constellation Ophiuchus as well. Now, the zodiac sign, if we trace this ecliptic, we would notice, so there's the scorpion, there's the bright star of Virgo, right? And there's Leo, right? The ecliptic goes through these particular constellations, and if you're paying attention, you might say, well, okay, wait a minute, Kevin, you went from Scorpion to Virgo. What happened to Libra? Okay, Libra's right here, these two stars. Okay, looks like we hit that one spot on just about. So it goes through those, but on its way over, so at this time of year, in the early evenings, Sagittarius is not quite out yet. On its way through to Sagittarius, it's actually clipping through part of Ophiuchus. Ophiuchus really deserves to be a zodiac constellation, but that would make it number 13. Okay, so that is not that is not commonly done in that system or that view of looking at the stars. So anyway, there's our night sky that we can see, but now let's hit the morning sky, because the morning sky is really what's going to be interesting to us the next few days. We'll just go into overnight here. Up there comes Saturn, came up at about a little before midnight, it looked like, maybe about 11. And there comes Jupiter about 1 o'clock. Actually, we're almost to 2 o'clock in the morning. And there's a bunch of them. There's the Moon and Mars now, 3 o'clock, which is this is almost 4 o'clock. So let's get to maybe around, let's see if 4:20 will work. Yeah, 4:20 works. Okay, and let's just bring that over a little bit there. And so here we are. So 4:20, this is 4:20 tomorrow morning. Okay, and in the east, looking toward the east, and starting from the horizon, Mercury is going to be the tough one. Mercury always is. Basically, it's a race between, can Mercury rise high enough in the sky above the horizon before the sky gets too bright, because the sun is like right behind it. But Mercury is actually a fairly bright object. I just do want to maybe just note that if you're looking for Mercury, you are looking near to the position of the sun in the sky, and you need to be careful, especially if you're using maybe binoculars or something. But you really don't need binoculars to take in this whole view. Maybe if you want to make sure you see Mercury. But so we have, and this is in their order of distance from the sun, we have Mercury, Venus, Mars, Jupiter, and Saturn. And notice, look at that ecliptic, right? So the other thing about the ecliptic is that all the planets orbit in roughly a plane around the sun, so that their apparent path through the night sky follows this ecliptic fairly closely. And you might see, nope, not exactly. Good old Mercury is actually the furthest off the ecliptic of all the planets. Venus a little bit off, Jupiter pretty close. Okay, and Saturn and Mars a little less close. This ecliptic also marks that, and these planets also show up against or in front of the zodiac constellation. So I think this is over here is Capricorn. Let's just click a star here. Yep, see Cap, right? That's in Capricorn, and then we're getting over to no, there wouldn't be Pegasus. It must be Pisces then. All right, Pisces is right below Pegasus. So we're seeing them, and that's another reason why all those constellations got a lot of attention. And then all right, so tomorrow we see the moon. It'll be a little past third quarter, I believe, moving to a crescent. Let's go one more day. And in that day, the planets may have shifted a tiny bit, especially Venus, Mercury, and Mars. They're close to us. We can see them shift a little bit, but the moon especially is going to shift a lot in its orbit around us. And let's go to so now on the day after tomorrow morning, now the moon has shifted into position where if we let the moon substitute for the Earth, now we have Mercury, Venus, Earth, Mars, Jupiter, and Saturn. And on Friday morning, the moon is like right in between Venus and Mars. Of course, it's going to be cloudy that day, right? And to have them in order like this, one thing that has to happen, in order for this to happen, Jupiter needs to be, let's just say to the left of Saturn. Really, we would need to say maybe it's to the east of Saturn. I'm sorry, to the west of Saturn. But it has to be on the correct side of Saturn. And when that happens, remember last December, the grand conjunction? When Saturn and Jupiter, basically Jupiter's on the inside track, right? And so as it appears to travel against the stars, it's going to go way faster than Saturn. And basically what happened last December is that Jupiter came, and as the days went by, passed in front of Saturn, almost literally, and then kept on going. So right after a grand conjunction, we have the setup with Saturn and Jupiter. And that's the critical one. They are so far away that basically they don't change very quickly and they don't change very much. It's going to take, I think, 2 years for Saturn to even just get through that constellation of Capricorn. Jupiter does it in 1 year. So that's the first key, is it's going to have to be pretty soon after a grand conjunction. And then, while Mercury, Venus, and Mars, they're much closer to us. They vary around a lot more, and then you can get that. So the previous ones of these have happened. Previous alignments like this have all happened in the year or two following a grand conjunction. Much more than that, and what happens is now Jupiter and Saturn get farther apart in the sky. Notice that you can see these all in sort of, I don't have to shift around too much, right? Really not at all. It takes up just maybe a little over a quarter of the entire sky to go from Mercury all the way up to Saturn. And if you get too many years past that grand conjunction, Jupiter has just moved too far away from Saturn for this to happen. This program is called Stellarium. I really should mention it's a free program. I really like to mention that because the folks who made this, it's a labor of love for them. They don't make this, you don't have to pay for this. And they do an excellent job of putting in the mathematics of this and putting the programming in so that these things show up right. And if we had time, we could explore this over the years and it would still be correct. But I do want to end up with a different program with similar thing called Celestia, also a free program, also for the people who make that a labor of love. And this is now, let's say we left our Earth, we flew straight up from the North Pole, far enough where we could look down, look back, and see all the planets in their orbit. And this is what they look like. This is what it looks like tonight. Now, one thing is that I'm going to have to come in a little bit to have Mercury really show up. So even though it looks like they're all strung out in a line out there in the sky, when we get out into outer space, that's not really what's happening. We just happen to, from our vantage point on Earth, we can just look out and see them pretty much in the same direction. But they're not nearly in a line. The Mercury, the dot for Mercury, in case you can't really see that, is right next to its name, Mercury, there on the map. So, and notice again, from the Earth to Mercury and looking from the Earth to the sun, that's pretty close, right? And just like in our night sky. And so now if we come back out a little bit, we bring in Saturn. And so they are, at least these are pretty much on the same side of the sun, at least as the Earth. Actually, the Earth is more separated from all of them, isn't it? And so it's not really a real lineup. It just looks like it to us from our Earth as we look out to Mercury and then Venus, then to Mars, then to Jupiter, and then to Saturn. We kind of see them visually, but we don't see, in the Stellarium view, we just don't see the 3 dimensions. Okay, and Jenny, thank you. Jenny has put some details on there for the program on July 12th, a 3 p.m. family program, 5:15 for astronomy enthusiasts. Really, anybody interested in astronomy, come on by at 5:15. It'll be a great event. It's going to feature a panel. A panel is going to of scientists is going to be broadcasting to us at 6 o'clock that night. And this is something that is only available to some of the NASA partners, and we're one of them. So hope to see you there at that event. Thank you to everyone for coming by tonight. Again, for AstroQuest, we'll see you in for AstroQuest, we'll see you in September, but do come by either. I believe we're going to do virtually as well, or else come on by the museum on the 12th of July, and we'll find out what has the web found for us first time out. And Jenny is confirming that we are really hopefully going to do this as a hybrid event. Okay, so everybody be well until then, clear skies until then, and we'll hope to see you soon. Take care, everyone.